Good morning, everyone. So today I'm managing a topic like what memory management or memory management for operating system. Now, just a minute. The memory management is a method for functionality of an operating system which handles or manages a primary memory. It is the process of controlling and coordinating computer memory, accessing portions called block to various running programs to optimize overall system performance. The memory management function keeps a track of the status of each memory location, either located or free. It determines how the memory allocate among the computing processes, deciding which gets a memory when they receive it and how much they are allowed. When the memory is allocated, it determines which memory locations will be assigned. It tracks when the memory is freed or unallocated and update the status. Now, memory allocation techniques, basically we have what? First thing, we have the memory management scheme. Continuous, in that the two parts basically we have. One is the continuous memory allocation, next one is the non-continuous memory allocation. And in continuous memory allocation we have the three things. We can call it as a bare machine, we can call it as a resident monitor, we can call it as the multi-programming. And again, if you see the bifurcation in the multi-programming, we can have the fixed partition and another one is the variable partition. And this side if you come, so non-continuous memory locations, again it is divided into a segmentation. You can call it as a user view, and the second part is the paging, the system view. Now continuous memory allocation we'll see one by one. Continuous memory allocation model that assigns a process memory blocks. For example, that is a memory blocks having a consecutive addresses. It one of the oldest memory allocation schemes. When a process needs execute a memory, it requires by the process the size of the process paired with the amount of continuous memory available to execute the process. Sufficient continuous memory amount, the process is allocated a memory to start execution. Otherwise, it is added of processes until sufficient free continuous memory is available. So it's called continuous memory. The next one is the machine, as we are discussed. So basically their machine is a logical hardware used to execute the program in the processor without using operating system. As of now, we have studied that we can't execute any process without operating system. But yes, with the help of the bare machine, we can do that. Initially, when the operating systems are not developed, execution of an instruction is done by direct on hardware without using any interfacing hardware. At that time, the drawback was the bare machine. Accepting instructions in the only machine language. Due to this, those programs who has sufficient knowledge of the computer field are able to operate a computer. So after the operating system, bare machine referred as insufficient. Now, for example, what are the advantages of it? The main advantage of a bare machine is what? One is flexible. Next one is no hardware support is required for this. Third one is the software is needed for operating system. For operating system, we require a software. Then the disadvantages of this, for example, and as a OS has no control over a memory, it does not provide any services resources to user. Such a management method is used for dedicated systems. Okay, used for all the machines. Now, resident monitor. What do you mean by that? This is called what? A process monitor. So basically, the resident monitor is a code that runs on bare machines. The resident monitor works like an operating system that controls the instructions and performs all necessary functions. Also works like a job sequence because it also runs the job and adds them to process. After scheduling, the resident monitors load the program one by one into main memory according to the sequences. One more important fact about resident monitor is that when a program execution occurs, there is no gap between a program execution and process going is faster. Now the resident monitor are divided into four parts. One is the control language interpreter, second one is the loader, third one is device driver, fourth one is interpret processing. So interpret processing, device driver, job scheduling and control language, it will come in the resident monitor, and there is a boundary. After that we get what? The user program area. So collectively we can call it as what? We can, as we shown in the diagram, there is a memory layout for resident monitor are divided into four parts. One is the control language interpreter, second one is the loader, third one is device driver, fourth one is interpret processing. So interpret processing, device driver, job scheduling and control language, it will come in the resident monitor, and there is a boundary. After that we get what? The user program area. So collectively we can call it as what? We can, as we shown in the diagram, there is a memory layout for resident monitor are divided into four parts. One is the control language interpreter, second one is the loader, third one is device driver, fourth one is interpret processing. So interpret processing, device driver, job scheduling and control language, it will come in the resident monitor, and there is a boundary. After that we get what? The user program area. So collectively we can call it as what? We can, as we shown in the diagram, there is a memory layout for resident